Hello everyone, this is Greg from ChemCore. In this video, we're going to be talking about IUPAC and naming branched alkanes. Now, if you haven't watched the instructional video on how to do this, or the topic video of how to do this, we went over a couple things, including kind of just basically what are IUPAC rules and blending in our previous knowledge of straight chain alkanes that we talked about in the past video with learning how to name branched alkanes. And this video was really important to understanding kind of the checklist method that I like to teach with naming pretty much all molecules. And really getting this down is going to be one of the main concepts, and kind of it keeps repeating. Okay, and so throughout this, we're going to use our concepts of straight chain alkanes and the rules of naming, and we're going to go through each question one by one and kind of figure out how to name, right? And so the first question, what is the parent chain of the following compound? Now, when it comes to parent chains, there's a couple kind of methods I like to do. Now, when you eventually get better at this, you'll eventually see them really quickly and you'll be able to move on. But for now, I want you to guys take it one time, like one method at a time or one option at a time, and really take it slow and get used to the method. Now, if you guys don't remember, parent chain of a branched alkane or branched hydrocarbon is going to be the longest chain, right? With a couple exceptions. Now, the exceptions will come later, but for now, the parent chain is going to be the longest chain. Now, I think like one of these probably look like the parent chain. So let me just trace this. Oops, let me trace this. Maybe something like this. That looks like it could be one of the longest chains, and it has 1, 2, 3, 4, 5, 6, 7, 8 carbons. Okay, looks like it probably will be the parent chain. Let's explore a couple of our options. 1, 2, 3, 4, 5, 6, 7. That's not going to be the parent chain. 1, 2, 3, 4, 5. That's not going to be the parent chain. And 1, 2, 3, 4, 5, 6, 7. Also definitely not the parent chain. And so our parent chain is definitely going to be this highlighted chain consisting of 8 carbons, meaning that our parent chain is octane. Now, in the second question, let's just go ahead with the same method. We'll have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 is the longest I have for now. 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 is my longest chain now. 1, 2, 3, 4, 5, 6, 7. It seems like this chain is going to be the longest chain, consisting of 9 carbons. Now, if you guys haven't guessed, I'm kind of like, I'm able to, with a lot of practice and with teaching this a bunch of times, I'm able to kind of see the parent chain right away. I don't expect you guys to be able to do this yet, but it's okay. The more practice you get, the better you'll get at it. The difference is that I'm able to see this, and it might take you longer. It might take you a couple combinations to go ahead and try, but eventually you should land with this. And so, the point is keep practicing, keep trying to find the parent chain, and eventually it'll click and you'll be able to see them a little quicker. Now in the next problem, let's use the same method. The first chain I see is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, 6. 1, 2, 3, 4, 5, 6, 7. 7. I think that will end up being my longest chain. That will end up the same thing. And so my longest chain is 7 carbons, which means it's heptane. Question 4 looks like almost a similar molecule. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And going this way is going to end up being the same thing. And so our longest chain is going to be octane. Okay. And after practicing putting together a parent chain, it's a good idea to start practicing actually putting together an IUPAC name. And so first of all, there was a reason why the first couple of questions I wanted you guys to find the parent chain, because the first step of an IUPAC name is to find the parent chain. And so let's do it like we practiced before. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Another 7 chain. Here's where the exception comes that I talked about earlier in this video. Okay. We have two options, right? We have two options. So I could go this way, and I could also go this way. And this part is in common, right, between the two chains. Which one would you choose? Does it matter? Now, pretty much every time I ask my students this who are teaching for the first time, they say, no, it doesn't matter. It actually does. So in this case, it actually does. In some cases, it won't matter, but in this case, it does. And there's a big difference why I will choose the first chain, or the second chain, actually. So if we were to look at the first chain, we kind of run into this problem, right? We see this kind of group, and think to yourself, at this point, how would you name this? Like, it's pretty difficult, right? Like, it's not an actual singular substituent, right? Compared to if you were to have this chain, something like this, the same one we drew before. Now we have a little bit more substituents. We have this one and this one and this one, but it's a little easier to name. And so the rule is when you're in between parent chains of the same carbon length and you want to choose one to become your parent chain, you want to choose the parent chain that will have the most number of substituents. And that actually makes sense because in the previous one, we only had 2 substituents compared to this 3. And the example I like to do of it is like a lot of students forget this rule and then they run into a problem where they choose a parent chain that has a group like this. And usually I like to teach this before we teach common names because this is a common name that you would be able to name. But that would result in a mistake. And so using this parent chain first, and teaching this topic first before you know common names actually helps you understand this concept a little better. If you were to name this as a substituent, you run into a problem. You'd be like, how do I name that? That doesn't quite make sense. Okay, so we got to the point that we understand that our parent chain is heptane. Now, the way I'm going to do it in front of you guys is the exact way I like to do it and how I like all my students to do it. The first thing you're going to do is you found your parent chain. You're going to write that parent chain somewhere along the side. Okay. Next, what I like to do is I like to go ahead and circle all of my substituents. So these are my substituents. I see 3 of them. And what I'm going to do is right next to each of the circles, I'm literally just going to write what that substituent is. So going from left to right, I have this one, right, which is just 1 carbon. I'll circle it for you guys. So we'll call that a methyl group. Makes sense. The next one, I see 2 carbons. We call this an ethyl group. And the other one, I again see 2 carbons, and this is another ethyl group. Okay. At this point, this makes it a lot easier to figure out, well, what do we do next? Remember that their next rule is, okay, which way do I number this parent chain? Do I number from left to right or from right to left? Well, I don't like students kind of guessing and doing it visually. When you're first learning this concept, I really like you to literally write down both variations. So let's try to count. This would be 1, 2, 3, 4, 5, 6, 7. So if we count it from left to right, our substituents would be on 2, on 3, and on 5, right? That makes sense to you guys? 2, 3, and 5. Okay. If we were to count from right to left, we would end up with 1, 2, 3, 4, 5, 6, 7. And so if we were to count from right to left, our substituents would be on 3, on 5, and on 6. And so now that you see these numbers, it's very easy to understand that we have to pick the first one, the first option, right? 2, 3, 5, because overall, right, you'd end up with a lower number count. And so let me undo all of these numbers. Here, now we have the numbering. We understand that we'll have 2 methyl, right? And be careful here. On the 3rd position and the 5th position, we have 2 ethyls. And so we'll actually kind of call this group 3,5-diethyl. Okay, so now we have our substituent names. We also have our parent name. Let's put it all together. Remember that this is like one of the biggest mistakes. One of the most common mistakes is students just put this in form of number, right? Okay, 2 comes before 3 and 5, so I'll put that in the name first. That's a mistake. We actually put it in terms of alphabetical order, disregarding prefixes. And so if you think that di is a prefix, which it is, and you use E and M, E becomes before M, and so your name should be 3,5-diethyl 2-methylheptane. Alrighty, and that matches up with answer choice E. See, like all these answer choice would lead you to a different answer based on like the mistakes you would do. I curate these answer choices very carefully. Remember to organize your names in organize your substituent names in form of alphabetical order, not including prefixes. Okay, for the next problem, let's do the same thing. Let's find a parent chain. Looks like this might be the longest. 1, 2, 3, 4, 5, 6, 7, 8. That clearly is the longest, but let's just check. 1, 2, 3, 4, 5, 6, 7. Yep, nope. 1, 2, 3, 4, 5, 6. Nope. And so this is our longest chain. No exceptions, no rules that we have to worry about. Our parent chain is very clear. And so let's write down that our parent chain name is octane because we have 8 carbons in our parent chain. Okay, let's circle our substituents. This one has only 1 carbon, so we call this a methyl. This one also has only 1 carbon, so again we'll call this a methyl group. And now let's figure out how to number this molecule. If we number from this way to that way, we'll call this 1, 2, 3, 4, 5, 6, 7, 8. So our substituents would be numbered 3 and 6. And now if we numbered the other way around, we would end up with 1, 2, 3, 4, 5, 6, 7, 8. And so again, our substituents would be numbered 3 and 6. So it actually doesn't matter at all. We can just go with our first option. It would be the same thing no matter what. Lucky us. And so remember that 3 and 6, since they're both methyl groups, we would call it 3,6-dimethyl. Let's just put our parent name in there already. It would be 3,6-dimethyl octane, which leads us to answer choice B. Question 7, we're doing the same thing, just finding the IUPAC name. Again, let's find the parent chain. So it looks like it might be from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7. Nope. So it does look like this would be our longest chain. Now let's write down our parent chain octane onto the side. Somewhere octane, so we don't forget. And let's circle our substituents. We have 1 here, 1 here, 1 here. This one has 1 carbon. And so we'll call this a methyl. This one has 2 carbons, and so we call this an ethyl. And this one has 1 carbon, and so we'll call it a methyl. And so let's figure out our numbering. If we number from this way, we'll have 1, 2, 3, 4, 5, 6, 7, 8. And so our substituents would be numbered 3, 5, and 6. But if we number it from the other way, we would end up with 1, 2, 3, 4, 5, 6, 7, and 8. We would end up with 3, 4, and 6. And so the numbering in blue would end up actually better. So this is the reason why I want you guys to try both ways. And this really gives you, maybe it spends a lot more time, but you'll never make a mistake going like this. And so let me just erase all our numbers, and I'll just rewrite them so that, you know, our screen is nice and organized. So now we know we have to start here. 1, 2, 3, 4, 5, 6. Oops, I missed the number. 1, 2, 3, 4, 5, 6, 7, and 8. And so our substituents would be on the 3 and the 6th position. We have 2 methyls, and so it ends up being 3,6-dimethyl. And on the 4th position, we have just a singular ethyl. And so remember that we need to organize, in our full name, we have to organize our substituents based on alphabetical order, not including prefixes. E comes before M, And so it would be 4-ethyl, 3,6-dimethyl octane. Okay, and so our full IUPAC name would be D, right? 4-ethyl 3,6-dimethyl octane. This one seems like a simpler structure. Let's see if it really is simple. We can try to find our parent chain by going 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Aha, again, we fall into our same exception. We have two options, right? And no matter which way we choose, it'll be 5 carbons. So is either of them correct? Doesn't matter? It actually does matter. And so if you look at this first option, we have 2 substituents, right? Okay. But if we look at the other option, we'll only have 1 substituent. And so using the rule that I mentioned earlier, okay, when choosing your parent chain, you have to use the parent chain that has the greatest number of substituents. And so this is actually our correct parent chain. It has 1, 2, 3, 4, 5 carbons, meaning that our parent chain name is pentane. Okay, and we have 2 substituents, one over here, one over here. Okay, this one has 1 carbon, and so we'll call this a methyl. And this one has 2 carbons, and we'll call this an ethyl. Okay, and let's figure out our numbering. So if we number from this way, we'll have 1, 2, 3, 4, 5. Okay, and so our substituents would end up with the numbers 2 and 3. And if we numbered from this direction, we would end up with 1, 2, 3, 4, 5. And so our substituents would end up with numbers 3 and 4. And so clearly the first way was correct. And so we would name our substituents 2-methyl and 3-ethyl. And to organize our name, remember that we have to put them in alphabetical order, meaning that our substituents would be 3-ethyl, then 2-methyl, and then our parent chain name, pentane. And so our answer should be E, right? In the next problem, again, we're trying to find an IUPAC name. And so this molecule, let's find the parent chain 1, 2, 3, 4, 5, 6, 7, 8. I mean, listen, you guys can try a bunch of different parent chain names, but I think I'm pretty confident that this is going to be our parent chain name. And this is called octane, right? That's our parent chain. Let's circle all our substituents. 1, 2, 3. So this one is a methyl. This one is also a methyl. And this one is also a methyl. Nice. And so if we number from this way, we'll end up with 1, 2, 3, 4, 5, 6, 7, 8. And our substituents would have the numbers 3, 5, and 6. Okay. And if we number from the other direction, 1, 2, 3, 4, 5, 6, 7, 8. Our substituents would be 3, 4, and 6. And so actually the second way was actually the correct way. And so our substituents would literally be called 3, 4, 6 trimethyl. And so if we were to put our whole name together, it would be 3, 4, 6 trimethyl octane. Meaning that our name should be C. Awesome. Okay, now question 10. Again, let's try to find a parent chain. I'll start from the left. Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That looks like it's going to be our longest chain. Okay, and so 7 means that our parent chain name is heptane. Let's circle our substituents. Okay, this one is 1 carbon, meaning that it is methyl. And this one is a little tricky. This one doesn't look like, you might be tempted to just write it as propyl because it's 3 carbons, but it's not exactly propyl. It would be propyl if it was attached like this, right? 3 carbons attached to blah, 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 something, but it's not quite that. In the common names video, this might make a little bit more sense, but for now, we have to somehow name this as a substituent of a substituent. Bear with me. So if we, let's erase this little circle for now. okay? So now imagine that this alone was our actual molecule. What would be the parent chain? Well, the parent chain would be this, right? 2 carbons, which is ethyl. And the substituent would be this, which is methyl. And so if we were to name this whole entire thing, it would be 1-methyl ethyl, right? If you had to name this, you can name it as a substituent of a substituent, meaning that this would be our parent chain, the short ethyl would be our parent chain, and this methyl would be our substituent. And no matter which way you count from, 1, right, would be the smallest number, meaning that this is the name of our full substituent. And so let's find the numbering of our whole parent chain, right? If we number from right to left, we'll end up with 1, 2, 3, 4, 5, 6, 7, meaning that our substituents would get 3 and 4. And if we were to name from left to right, we would be 1, 2, 3, 4, 5, 6, and 7, meaning that our substituents would be 4, and 5. And so the first way was actually correct. And so we can put together our names. It would be 3-methyl. And now the tricky part is 4. How do we name this? We would put this in parentheses as 1-methyl ethyl. Okay? And so realistically, it's kind of difficult to put it together as a kind of alphabetical name. And so we consider this M as being in front of this whole alphabetical name because it's kind of huge. And so our name should be 3-methyl, 4,1-methyl ethyl, heptane. Excellent. And so our answer is D. Okay, question 11. Let's again find our parent chain. 1, 2, 3, 4, 5, 6, 7. Okay, that's an option. 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons is probably going to end up being our longest chain. And so that's octane. And so now if we wanted to circle our substituents, we would end up with 1. And then here, so this is 1 carbon, we would call it a methyl. And here we kind of run into a similar problem where we have a substituent of a substituent. And so if I were to, let me just erase the circle that we drew before. If we were to just zoom in, just single out this substituent, what would be the parent chain? Well, it would be this, right? These 2 carbons, which is ethyl, right? And the substituent of that would be this, which is methyl. And so the name of the whole substituent would be 1-methyl ethyl. Okay? And so let's figure out how to number our molecule. If we number from left to right, we would end up with 1, 2, 3, 4, 5, 6, 7, 8. And so our substituents would get 3 and 5. And if I were to number from the other way, we'd end up with 1, 2, 3, 4, 5, 6, 7, 8, meaning that our substituents would be 4 and 6. And so the first way we actually wrote was correct. Let's clean that up. And so the names of our substituents would be 3-methyl, and then 5, parentheses, 1-methyl ethyl. And so if we were to put together the whole name, like before, it would end up with 3-methyl, and then 5,1-methyl ethyl. And then finally our parent chain comes in with octane. And then finally our parent chain, octane. And so the correct answer is E. All right, now the last multiple choice question, figuring out the IUPAC name. Again, let's just find the parent chain. So 1, 2, 3, 4, 5, 6, 7. I know this kind of looks weird. Sorry, it was generated in a weird way. So 1, 2, 3, 4, 5, 6, 7. So we have 2 options, right? We can go this way or that way, and it would end up being 7 carbons anyway. And so now this is where you want to compare. We want to find the structure that has the most substituents. We would end up being this, right? Very clearly, we would end up with 1, 2, 3, 4 substituents, and the other one would end up with like 3 substituents. And so this one has 1 carbon, which is a methyl. This one is also a methyl. This one is also a methyl. And then this one finally is a propyl. So I forgot to write down our parent chain name. Should be heptane, right? 7 carbons. Okay, let's figure out how to number this carbon. So if we were to number from left to right, we would end up with 1, 2, 3, 4, 5, 6, 7. And so our numbers would be 3, 4, 4, and then 6. I'm writing 4 twice because we have 2 substituents on that carbon. And if we were to number from right to left, we would end up with 1, 2, 3, 4, 5, 6, 7. And so our substituents would get 2, 4, 4, 5. Clearly the second way is better. So let's clean that up a little bit. Let's rewrite those so that we just have a clean slate. 5, 6, 7. And so our substituents would be on number 2, 4, and 5. We have trimethyl. Oops. And then on substituent 4, number 4, we'd have 4 propyl. And so now, well, what comes first? M or P? Remember, we don't consider the T. And so M comes before P, and so we'd write this full name as 2, 4, 5 trimethyl, 4 propyl, and then our parent chain name, heptane, meaning that our answer is C. All right, now a little change of pace. For now, well, this whole worksheet, we've been trying to take a structure and give a name to it. Well, now let's try going the other way around. Let's take a name and try to write a structure. It helps going both ways because it really helps solidify these concepts. And so before we kind of started with the parent chain, guess what we're doing now? Starting with the parent chain. The rules are all the same. So as long as you're able to identify, hey, in the first example, we have heptane. So let's just draw a heptane, the simplest heptane we can figure out. 1, 2, 3, 4, 5, 6, 7. That's a heptane. And now our substituent seems to be 4 isopropyl. Now, if you're not familiar with what isopropyl is, I suggest you go watch the common name video. This will make a lot more sense. So let's just find 4. 1, 2, 3, 4. 4 is going to be right here. And remember, isopropyl looks like this, right? With attached to whatever, blah, blah, blah. And so our bond line structure should look like that. Now the next structure, again, we have hexane. So that's our parent chain. Let's draw it. 1, 2, 3, 4, 5, 6. Our first substituent is 3 ethyl. So let's count 1, 2, 3 ethyl. And our second substituent is 2 methyl. Done. Pretty simple, right? And our last 2 structures, our parent chain is pentane. So let's draw a pentane. And then our substituents are 2, 2, and 3 trimethyl, meaning that we have 2 on 2 and then 1 on 3. And then our last example, we have a parent chain heptane. And 3 and 4 are going to be dimethyls. 1, 2, 3, 4, 5, 6 is going to be ethyl. And that's our final structure. All right, this concludes our explainer video on the IUPAC and naming branched alkanes worksheet. Again, if you're unfamiliar with these concepts and you just want to brush up on them, go watch the instructional video. It's linked in the description below. If you haven't had a chance to look at this worksheet and you really want to, or look at the answer key for this worksheet, again, linked in the description below. And I'll see you guys in the next video.